All right, example 3, calculating work. A 50 kilogram mass, okay, that's mass. Let's see, what did we do mass as? Did we do mass for anything? We sure didn't. Okay, let's just make mass orange. Straight up at a constant velocity, that's a good thing to note. I am just gonna, circle that to a height, of 20 meters. That's our displacement right there, is 20 meters. Okay, all right. Let's see, what is the magnitude of the force of net force? Well, remember, constant velocity, means zero acceleration. And if there's zero acceleration, that means my net force is zero. That looks like it says on. How do I know? Constant velocity means no net force, or zero net force. What's the equation for force due to gravity? Aha. Remember, Fg, which is weight force, is equal to the mass. Let's go ahead and make that orange. I'm going to undo that. Mass times g. Do y'all remember what g is? That is the acceleration due to gravity, which is, remember, 10 meters per second squared. You could use 9.8, it's fine too, That's actually more accurate, but remember we just said we're going to use 10. So now when we calculate it, my mass, up there it said 50 kilograms, and we're going to multiply by 10 meters per second squared. This gives us a force of, I'm going to write it in blue because it's a force, 500 newtons. I should just remind you, and I'm going to put it in here too, that G, remember, because it's downward, we tend to say that upward is positive. And so because acceleration due to gravity is downward all the time, we're going to make him negative, which means this over here is negative, which means our our force is a negative force. Okay? Then what we'll see is, it says, what is the force due to tension? Well, if gravity is negative 500, and we know that F net, I should maybe write it where it's asking me to write it. Let's see. How do we know? We know F net is equal to Fg plus Ft, If we were to draw a free body diagram, that's what we're drawing. This being lifted up is Ft. This force from that box is Fg, And they have to be equal to each other because F net has to be 0 newtons. So if my force due to gravity is negative 500 newtons, what would Ft be if it were 0? It would have to be 500 newtons, positive. Positive 500 newtons, okay? What is the displacement of the mass? The problem gives us that, 20.0 meters, okay? What is the work done by the force of gravity versus the force of tension? Okay, well, the force of gravity and the work done by the force of gravity, is we're going to take negative 500. Actually, I'm just going to go ahead and write work is equal to, remember, gravity is opposite the motion, We know that the object is actually moving upward. Moving upward. So the force of gravity, right, is opposite the motion. This guy here is opposite the motion. This guy here is the same direction as the motion. So gravity, right, we're going to do the negative FD equation, and we know that that negative is the negative 500 newtons multiplied by my displacement, which is 20.0 meters. When I multiply that out, my work ends up being negative 1,000 joules. Remember, work is energy. Then the force of tension is W is equal to positive force times displacement. And so we see that that is equal to, let's see, 500 newtons, right, multiplied by 20.0 meters. And this would end up being positive 1,000 joules. The work done by the net force formula, net force is 0, so it has to be 0 joules.